Okay, so we're going to start chapter 7 by looking at exponential equations. So that means we do need to look at some exponent rules really quick. So if you ever see something with a fraction, that means we can also write it with a negative exponent. And off to the side, if we see that we have anything to the 0 power, that means it's equal to 1. And so we'll be flipping back and forth between those representations. Also, for the steps on how to solve those exponential equations, we're going to make the bases the same, and then we're going to set our exponents equal. So our first thing is to make the bases the same for our first question. So for our first one, we're solving, and our bases are not the same, right? 2, 16, not the same, but I can rewrite 16 as 2 to a power so that the bases are the same. And 16 is actually 2 to the 4th power. Now after that, since our bases are the same, we're going to set our exponents, the little guys, equal to each other. And so we'll get x is equal to 4. So that's the basic premise. Obviously, we're going to move up from there. In this example, we have 5 to the x is equal to 1 over 25. So 5 is already something I can't really change as a base. But can I write 1 over 125 as 5 to a power? I can, because the 125 is actually 5 cubed. And it's just like 1 over 5 cubed. And so to change that 5 cubed into 5 to a power, it's a fraction. So I'm going to make it a -3. So then my bases are the same. X is equal to -3. So if you ever see a fraction, that just means when you convert it, you're going to have a negative exponent. Moving on to another example, you'll see 3 to the x is equal to 1. That looks a little off. We have 3. That 3 to the x isn't going to change. But how could I write 1 as 3 to a power? We have to remember our rule that anything to the 0 power is equal to 1. So if I were to write this, 3 to the 0 power is actually equal to 1. So then I'll get my bases are the same, and I'll get x is equal to 0. So that's going to be a special case. So if that 1 ever pops up, we got to remember that anything to the 0 power is 1. So anything, any base to the 0 power can replace that 1 that we have. Then our last example for this video is 4 to the x is equal to 128. So 4 to the x power, I have to think, can I write 128 as 4 to a power? And it looks like 4 squared, 16, 4 cubed, 64. 4 to the 4th does not equal 128, because that should be like in the next thing. So I can't really write 128 as 4 to a power. So I have to look at a number that I can write 2. I can convert 4 into something. And I can actually convert that to 2 to a power. Right? It's 2 squared. And so I'm going to look at 128 and see if I can convert that to a power. So that'll be, now I'm going for 2 to a power. So 128 is actually 2 to the 7th power. So now I've got to look at what I'm supposed to do with this, like 2 and the x. These two will be multiplied, and it'll be 2 to the 2x is equal to 2 to the 7th power. So if they don't match up, like 4 can't be multiplied by itself to get to 128, we got to look for a number. They can both be written in the form. So now we'll have 2 to the x. Oh, we want to just write 2x is equal to 7. We can write it as 7/2. And that's it for the first part of exponential equations.